Hey guys, Chris here, and I wanted to put up a quick video to show just how useful 3D printers and 3D printing can be when repairing, electronics and, other small, things, I guess. But in my instance, I have a little receiver that has a part that's broken, and I'm pretty sure that I can use 3D printing to repair this part that would be difficult to replace otherwise. And well, let's see how it turns out. Let's go ahead and introduce you to the unit that has the problem. Okay, so I just picked up this Yamaha receiver, and I knew it had a problem when I got it. It's not a functional problem in that it still works fine, but this knob, it's real loose, comes off, and it doesn't, you can kind of turn the volume up and down, but it's still real loosey-goosey and it just falls off. So you can see, I don't know if you can see how that these tabs that go around the sort of the shaft of that, it's either a potentiometer, I think it's an actual potentiometer in there, that wraps around that potentiometer. They've just kind of loosened and flared out. So this is what we're going to fix. We want to get these tabs to grip tightly around that potentiometer shaft again. Okay, so there's my issue. This AV receiver has a volume knob that it's a little wonky, right? I mean, the tabs that hold that knob on the potentiometer shaft have they fatigued, I guess, and maybe somebody ripped them out or pulled that knob off in a weird way, and it bent those tabs, and now they just don't fit around that shaft anymore. So what I thought I would do is I would just create a collar that would fit around those tabs and constrain them to keep them into the position they need to stay. And, really the collar itself is going to be what bears the load, whereas the thin plastic, and the thin plastic wasn't very good anyway, it was going to break. So this is my solution, by the way, and I've already created this, and I've even printed these, but we'll get to that later. But let me show you how I created these pieces, because it's super simple. So right now I'm in Tinkercad, and Tinkercad is just one of many 3D modeling resources you have available to you. Many free. This one's free. I often use a program called Fusion 360 as well. It's also free to people who aren't going to make a lot of money with the models that they produce. So pretty much hobbyists and even small businesses can use Fusion 360 for free as well. But there's many other. FreeCAD, I think, is something a lot of people use. I also used to use SketchUp for making similar objects. So anyway, we are in Tinkercad, and we're going to create these little hollow cylinders. And so the first thing you do in Tinkercad, if you're going to make something like this, is I need to pull in a hollow object. We're going to pull in a cylinder, and this is how Tinkercad works. You just grab objects, and once you pull them into your work area, you can manipulate them in many different ways. So the first thing I need to do is make this hollow. So this shape represents the hollow area. So now I need to dimension it, and right now it's 20. I need that to be 8.3. And how you get these numbers is you're going to have to probably have some calipers handy and measure your parts. That's really the best way to do it. So another trick I like to do is whenever I'm working on this plane right here, and I want my hollow object to cut all the way through my solid object, I want to just pull this down through through this plane. You know, it's just a good idea. It's probably not necessary. It was necessary in previous versions of Tinkercad, but let's just pull that down just a little bit so we make sure we completely pierce through our solid object, which is the next thing I'm bringing in. So here's my solid object, and this is going to become the ring or the collar that I'm making. So we need to dimension this down as well. So I want to have a 1 millimeter thick wall that, you know, is going to go around that those tabs. Since this is 8.3 and I need this to be 10.3, that'll give me 2 walls on either side that are 1 millimeter thick. So okay, and the last thing I need to do is I need to get my height. Now I determined that I have 6 millimeters of space underneath that knob, so I don't want to make this collar that full height, so I want to make it 5 millimeters. Okay, that has my object size. Now all I need to do is bring these parts together and create one part. So to align these parts, this is one of the things that Tinkercad is really good at, is I select both pieces and then I go up here to this little icon and click it. So now we are into the alignment mode. So I want to align in the X and Y, and there we go. We're completely aligned and set up. So I want to go ahead and click out of this. It's always good to leave that mode before you do anything else, and then I want to reselect. Okay, so just drag another box around those two objects, and now we've selected both objects and we need to combine these. And to do that, we go up here to this little icon, which is the group icon. Click that button, and now we have combined those two objects and grouped them and created one object. The hollow object, when combined with a whole object, the hollow cuts through the hole. And there we go. That's it. You know, whenever you're not explaining how to do this and filming it, this object takes like under a minute to make. And that's it. I'm done. So now the next thing I want to do is I want to export this onto my computer, because right now this file is in the cloud. I hate the cloud, but it's something we have to deal with today. So let's get this file onto my computer, and so we select it, and I don't know why those black boxes pop up. It's either an issue with my computer and Chrome, or it has something to do, it's a bug with Tinkercad. It doesn't affect anything, it just pops up from time to time. So I just select that object and go up here and click on export. So I want an STL, that's my file of choice. And now I need to choose, I need to get a name. We're just going to call this Yamaha knob collar. Okay, and that's it. We've taken the file and we've transferred it to my computer, and we're done. So the next step, I need to move into the slicer. So I'm now in my slicer, and what a slicer is a program that takes usually an STL file, but it takes a 3D model file and converts that 3D model into another file that is a set of instructions that your 3D printer can read. Now those instructions will be XY coordinates and other speed instructions for, you know, how fast or slow you'll be pumping out the molten plastic. And that's what the slicer does. It creates those text files which tells the 3D printer how to move its parts and what speeds in order to create the 3D, or the actual plastic object. So we're in my slicer, which is Simplify 3D, which, by the way, there's plenty of slicers out there. This is a paid program, that I paid a decent amount for, and that was a couple years ago when there weren't as many good options for free slicers. There's plenty of free slicers out there. I don't think there's any reason to pay for a slicer today because there's plenty of other good options available. Simplify 3D is great and I love it and I'm glad I have it, but if I was to make the decision today, I'm not sure I would have bought it. Okay, so now we need to bring in our 3D model, and to do that in Simplify 3D is you click on the import button. Not important, it is important, but we're going to import something that's important, and I have my Yamaha knob collar STL. Double click that and there's our part. And so that's it. The next step is I think I want to create a second one of these just in case I have my height wrong. I want to go ahead and create another one just in case I need a smaller part in the Z axis, the Z dimension. So to do that, first thing I need to do is I select my part. Control C will copy, Control V to paste. So now I've pasted in a new part. One nice thing you can do in a slicer is while you can't make detailed changes to a 3D model, you can change scale. And so for this, I'm going to scale it in the Z dimension to just make it a little smaller. So the first thing I need to do is I double clicked on the part. I'm here in my scaling segment of this little tab. Click off uniform scaling, and now on the Z axis I'm going to change that. Click the down button 1. Okay, we're done. So this part is 5 millimeters tall and this part is 4 millimeters tall. So just in case I need a slightly shorter part, I've got that covered. This is such a small part that uses such a small amount of plastic that it's not such a bad idea to maybe plan on making a mistake ahead of time and then cover that mistake in your print. Okay, so now the next step is I need to make sure my printing settings are correct. And this is not hard at all because pretty much every printer and every slicer has profiles available for each other, right? So in Simplify 3D, to get a profile for your printer, you just go to the Configuration Assistant and then select your printer, and it has all these printers available. So pretty much whatever printer you have is going to be in there, or something similar enough that you can use that profile for your printer. Now I've already got my printer profile loaded up, so I'm good to go. The other setting I would like to change here is I want to make sure that these parts have a nice wide base. You can see how thin these walls are and how small the parts are. They're 10 millimeters wide. There's not a lot of plastic that's going to be holding them down onto the build plate. So what I want to do is create what's called a brim. And a brim is basically rings of plastic that will enlarge the base area. That's it. Just adds width to the base so it's able to stick to the build plate better. In Simplify 3D, I go into my settings menu, and here are all the settings that you can change if you feel like it. But like I said, if you have a good profile, you don't need to worry about any of this. But for the brim, if I want to add a brim or a skirt is a similar addition to your print. The difference is a skirt will have an offset, so it's basically rings that are not connected to your part. You would add that if you need to kind of clear out your nozzle ahead of time before you start actually printing the part, which is useful. The brim does basically the same thing, but it's connected to the part. So you see I have 0 offset chosen, 1 layer. You only need 1 layer for this, and then I've chosen 12 outlines. The reason I chose 12 outlines, and you don't need that many, sometimes it depends on the part, but this part is so small I wanted to have a real wide base, and also by having 12 outlines the two brims merge into one, which effectively makes these two parts one part, and it makes this individual bases one base. So it's a really nice strong base for these parts to help them print. Okay, that is it. That is it. So now I'm ready to prepare this to print, and that's just this button right here. The slicer, this is one thing that Simplify 3D is really good. It does its thing really fast. Slices this, slices the model and turns it into instructions almost instantly. Even really large models, it doesn't take very long for Simplify 3D to create the file. So this is a visual representation of what the physical model is going to look like and how it's going to print. These individual lines are strings of plastic that your printer is going to lay down. So that's how your 3D printer is going to build these parts. And with most slicers, you can even see exactly how the printer is going to lay down the lines of plastic. So I'm pretty happy with what this looks like. Now I'm going to save this to my hard drive. Just save to disk, Yamaha knob collar. And that's it. My file is now on my hard drive, and I'm ready to move that file to my SD card, and then I can put the SD card in my 3D printer, choose that file again in the 3D printer menu, and print. And then according to this, it'll take 7 minutes, and this part will become a reality. Okay, so I've actually already printed these. Let's go see if this works. First off, this is such a simple way to repair a problem like this. And I love how 3D printing allows me to just come up with an idea, try it out, and sometimes it works, sometimes I have to iterate. And this was my solution to this problem. This particular collar ended up being just a little bit too small. With it being flared out already, it was hard to judge how big I needed that collar to be. So I made two options here, and even in two different heights. But one of these is 8 millimeters ID, and the other one is 8.1 millimeters ID. Turns out that was just a little bit too small, so I came up with my second iteration. And all I did was change the size, just up the inner diameter by 0.1 millimeters, and then another 0.1 millimeters. So I have 8.2 and 8.3 inner diameter for these. And I can just slide this on here, and there we go. It keeps that, gets right there in place, holds it tight. Now I'll probably, I think it should be this one, it should be the 8.2. I'll probably use the shorter version. And that should work. Here we go. Just rip that off. And that'll be my solution to this problem. So we need to clean this up a little bit. So I'll take off the brim, and there's also just a little bit of like ooze out on the inner part of the ring too, at that part. So first let's get this cleaned up. Okay, so now the next step is to test fit this on the receiver, and we should be done. All right. Okay, this is where the rubber meets the road, I guess, and we'll just try to put this in place. There we go. Just pretty good. All right. There we go. I'm going to call that done. It's a nice snug fit. It turns with no slop, and it still comes off. but it's not so tight that it's overly difficult to do so. Okay, I think that little fix is done. Okay, well, I am pretty happy with how this project turned out, because this little part really worked well for the function I wanted. And while it's not a, this wasn't a really hard thing to make, and I'm not trying to show how smart I am or anything. I really want to show how easy it is to make parts like this and to fix things that would normally be difficult to fix. I mean, my other solution, I guess, would have been to glue that knob, onto that shaft, and that's a horrible way to fix that problem. And but with 3D printing, anyone can make these sort of fixes, and anyone can do it. So, well, that is my little video for the day. I'm glad this worked out. I have a receiver that I can actually change the volume on, and that is it. That is it. Okay, well, thanks for watching. I hope you learned something, or at least enjoyed this, and I'll see you next time. All right, take care.